Bienvenidos, Ushamdeed, and welcome to this HUD-8 techtorial on Cisco's Enterprise Networking Security and Automation ENSA CCNA version 7 packet tracer activity. In this packet tracer activity, 10.2.6, we're going to be taking a look at how we can use the standards-based, in other words, non-proprietary link layer discovery protocol LLDP to map a network. Now, in the previous video, we looked at using the Cisco layer 2 proprietary protocol CDP, or the Cisco Discovery Protocol. Now we're going to be taking a look at a standards-based layer 2 protocol that would allow heterogeneous devices to communicate with each other that same information or similar information that we saw in CDP. Now, LLDP is defined in IEEE 802.1AB, and that's a capital A and a capital B. Now, it's almost identical to CDP because, as often is the case, Cisco, seeing a void in the marketplace, developed and produced CDP, the Cisco Discovery Protocol. And there was no standards-based solution at the time. Fast forward to LLDP, or the Link Layer Discovery Protocol, which is a standards-based sort of solution, very, very similar to CDP. In fact, some of the commands that we're going to be running are going to be almost identical to the commands that we ran with CDP. Now, remember, this is a layer 2 protocol, which means layer 3 connectivity is irrelevant. As long as we've got layer 2 reachability, this sits on top of Ethernet. We're going to be just fine, just like CDP. So let's go ahead and dive in and take a look at this packet tracer activity. The topology identical to the topology we used in the CDP video. And in fact, there's the map that we're going to be completing up top, or gathering the information for. There's our username and password information. I've actually written the password down so I don't have to roll back. So let's go ahead and dive in. Now, you'll notice it says we're going to be accessing these devices using SSH. A very important note, that is not the number 1. That is an L. And I mentioned it in the CDP video. For new learners who are newly being exposed to Cisco Packet Tracer, and to SSH for that matter, they typically see that and think that it means -1. And then they end up with an error message. Remember, that is a -L. So let's go ahead and jump on the admin PC here. And let's pull this down and give ourselves a little more space with which to work. We'll get a little bit more room here. And we'll come over to the desktop. We'll come to the command prompt. And the command prompt is extremely small. So let's do this. Let's come up here to Packet Tracer Preferences. And let's take a look at the font, which I thought we had blown out to the largest size. It appears that I didn't. And so this is how you would change the font. I like to call these fortuitous failures. Did a previous video where I didn't need to make the change because I had already made it. For whatever reason, we've got to make the change again here. And also, just a quick note, I am using the latest version, just recently released here, of Packet Tracer 7.3.1.0362. And so I highly recommend you go get that. And I have a video on YouTube on my channel that shows you how to do that. So let's go ahead, let's pull this back up and let's check right away here. And there we go. A little easier to read, right? A little more room with which to work. And so let's go ahead and say SSH -L admin 01, and we're going to go to 192.168.1.1. Now, that is probably the edge router. I'm looking up here to see. Yeah, that's going to be our edge router, and that's probably going to be that interface address right here, and we'll be able to check that shortly. Let me get the password in here. 3CRE7PA55. All right, so we are on this edge router. If I say show IP interface brief, we can clearly see that that gig 00 interface, which is going to be that inside interface here on this edge router, does have the address 192.168.1.1. Now, quick note here, remember the user, if I was to say show run, and can we get the username? As you can see here, we've got the username admin01. The privilege on this account, which is locally defined, in the local database on the router is set to privilege level 15. And so what that means is when we log in as the user admin01, we go directly to privilege exec mode. I'm not in user exec. I'm in privilege exec, which is going to allow me to transition to global config mode immediately and not have to come to privilege exec mode, which is this mode here. Typically, you'll see with the pound sign there at the end of whatever the prompt is that you have set, right, for the host name. Okay, so we are here, and the edge router was previously configured to use CDP. Switch 1's already been configured to use LLDP. Now, we cannot get onto switch 1. You can see the configuration is locked, and so we're going to have to, sorry, we don't need that. We'll use this right here. We're going to have to trust that they correctly configured switch 1, and we're going to find out whether or not that is the case. So it wants us to say show CDP. Sorry, I'm trying to get the prompt back here. It wants us to say show CDP to see what's going on here. And you can see global CDP information. We are sending CDP packets. That is the send time, right? Every 60 seconds. The hold time is if 3 of those packets get missed, the CDP information for whatever the device is that we might be receiving CDP information for, we're just going to go ahead and purge that information, and we're using CDP version 2. Again, automatically set to CDP version 2, and, excuse me, remember that we typically aren't going to be manipulating those timer values, right? We typically don't manipulate these timer values, but you could do that with CDP. So we're going to get into global config by typing configure terminal or simply conf t. I'm then going to say no CDP run. And now what that's going to do is that is going to globally on every interface on this router, and I say every interface on the router, we're looking at 2 interfaces here, right? We've got that serial interface and we've got the gig 00 interface. So on those 2 interfaces, CDP is now disabled. If I was to come back and rerun, let's come back and rerun that command and say do show CDP, you can see that CDP is no longer enabled. So before it was enabled by default, and we went ahead and we turned it off. So now LLDP can be configured. And this is a major difference between LLDP and CDP. Is there's mutual exclusivity, right? Or the sending and receiving, or the transmitting and receiving of LLDP messages. Those are mutually exclusive if you want them to be. And what I mean by that is you can only send LLDP messages or only receive LLDP messages if that's what you wanted to do. So if you had an interface on which you only wanted to receive LLDP messages and not transmit to give away information, you could do that, right? And just like CDP, I can enable LLDP globally on every interface. And if I do that, what I'm doing is I'm saying I want every interface that's enabled on the router to send and receive LLDP messages. And so we're going to dig into this a little bit further, excuse me, as we go along here. So that's exactly what we're going to be doing out of the gate right here, right? It says LLDP can be configured to both transmit and receive. And so let's go ahead and enable LLDP. And I'm going to say LLDP run, and we do this from global config. Now, if I say do show LLDP, excuse me, you can see we see just like show CDP, right? The status is active. Now we see the send timer and the hold timer, right? And you can see here that the send timer is every 30 seconds as opposed to every 60 seconds. And the hold time is 120 seconds as opposed to 180 seconds with CDP, right? Now, again, the same rule applies, right? If I'm receiving information and if I'm receiving information from a device and then that device disappears for 3 send timer values, or should I say 4 send timer values, 120 seconds, and it disappears, then I purge that information. I'm no longer going to be keeping information about that neighbor. Now, what we need to do here is we have security at the top, at the forefront here. And so right now, I'm sending and receiving information. In fact, let's see if it do show LLDP, and let's see if it's going to let me do that interface command, interface, and I'll try interface gigabit Ethernet 00. Let's see what we get. Yeah, so it doesn't like it. Now, that is a legitimate command. We're going to dive into that when we look at our packet capture. So that's going to show me specific information about an individual interface that I'm interested in looking at when I don't want to say something like show LLDP neighbors detail, right? Where I get a whole host of information. I just want to see information about a specific interface, and that is a legitimate command. It's not supported by packet tracer, so we'll circle back to that. So let's come back to the activity here. Let's get into interface gigabit Ethernet 00, and let's say no LLDP transmit. And again, this is a security consideration here. So on the edge router, I want to receive the information from switch 1, but I don't want to transmit any LLDP information to switch 1. Now, you can see it's going to have us use that show LLDP neighbors command, right? A nice, concise output. And I want you to keep in mind here the similarities between LLDP and CDP in terms of the information that's being displayed. Now, one of the significant differences here, and let's get ink to go up here. One of the significant differences here is you can see the capability B. Right? Now, this is switch 1's capability, because remember, I'm not transmitting any information to switch 1. I'm just receiving the LLDP frames from switch 1. So here's the device ID, very similar to what we saw with CDP. The local interface, that is the router, the edge router's local interface. We see the hold timer value. And the port ID is the switch 1 interface. This is the interface on switch 1 out which switch 1 is sending these LLDP packets. Now, let me call your attention to the capabilities. Remember, when we looked at CDP, for switching capability, we saw an S. Here we see a B, which stands for bridge, right? Remember, bridges and switches are both layer 2 devices, right? Pure layer 2 devices. We're talking about a layer 2 switch. And the bridge preceded the switch in terms of hardware, where we had bridges a very, very long time ago, and then they progressed to switches. And the difference, if you're wondering, was that with bridges, generally the bridges were software run, right? Or they were driven by software, where now with switches, we have hardware switches, where bridges used software. And I say in order to do the layer 2 functionality. Okay, so there is the port ID, and that's the remote port, right? So now we've got some information here that we could use to sort of fill in that chart at the top. And so that's the basic breakdown of LLDP. Let me erase the screen here, and let's go ahead and regain control of the cursor. And that's about it. And we, obviously, how many entries? We've got 1. And so we're able to see some of that information, and we are receiving messages. Now we're going to connect to switch 1 with SSH from the edge router using the admin 01 credentials. And so let's go ahead and jump on to switch 1 here. They give us that information. So SSH -L, right? That's not the number 1. -L, admin 01, 192.168.1.2. And the password I've got written down here, S3CRE7PA55, or @55. All right, so here we are. So let me ask you, on the user account on switch 1 for admin 01, is the privilege level set to 15? What do you think? You see, I can't even get the running config. So let's go ahead, and we don't need to get into privilege exec, and that's a good note. I don't need to get into privilege exec to run the show LLDP neighbor command. And you can see we don't see any neighbors because on the edge router, we've disabled the LLDP transmit functionality. It's not there, right? It's not there. Some of the other differences you may notice here, if I was to kind of scroll back up, some of the other differences you may notice, there's nothing here in terms of, what are we looking for? I want to say IGMP, but maybe that's going to come in a later. Maybe they'll mention something like that later on, or if we did a show LLDP neighbors detail, you can see we've got no information there. And so let's exit off here and let's come back to where we do. So let's say, oops, sorry, show LLDP neighbors detail, and there we go. So this is where we're getting some different information. Again, more information, just like with the CDP neighbor detail command, but we're getting some additional information, and we're getting information that is going to be a little more verbose, a little more specific, right? Right here, the system's capability and enabled capability. Now, this is going to be a good time to transition out to real Cisco routers, right? We're going to go to real Cisco routers here. And we've got Wireshark, right, where we're going to be doing a packet capture. So let me kick that packet capture off. Oops, let's come back here. All right, we'll kick off our packet capture here, and let's come over here to some real Cisco routers. So it says router 3 here. Just pay no attention to that. We've got it listed as router 14 right now. Show LLDP, right? You can see that LLDP is not enabled. Now, something that I think is interesting, and this is an interesting point, if you're looking at any of the sort of certification documents, right? Or the certification texts, specifically the official cert guide for CCNA talks about LLDP and configuring LLDP, and specifically the LLDP transmit and receive commands that are run on the interface. And we already saw how to do that, right? We would say LLDP transmit or no LLDP transmit, or LLDP receive or no LLDP receive, depending on what it is we want that interface to do. And if I said in global config LLDP run, and let's take a look at that. If I say LLDP run, and then we say do show LLDP, you can see that it's saying that LLDP is active. If we go to our packet capture, take a look at that, right? You can see we've got all kinds of LLDP multicast frames going all over the place here, and we're going to dive into those frames in just a second. But what I want you to notice is when I say LLDP run in global config, all the interfaces that are enabled on this router, right, are going to be sending LLDP packets. Now, I found that it was interesting that in the official cert guide for CCNA 200-301, which is the most recent CCNA certification that's out there, it mentions the transmit and receive LLDP commands, and it says the following. It says that an interface subcommand that defines the operation of LLDP on an interface, on the interface regardless of the global command. Right, and it says that for both transmit and receive. Let me repeat that. An interface subcommand that defines the operation of LLDP on the interface regardless of the global command. In other words, I can override the global command, right? And this is very, very important, like we just did, right? So remember that. If you say LLDP run in global config, you are sending and receiving on every interface on that router. Obviously, we're assuming here that the interfaces are up, right? So you're sending and receiving on every up interface on that router or on that switch. And that might not be what you want to do. And so let's drop back here. Again, I just want to make sure I covered that a couple times, because that can sometimes become confusing for learners. They think that if I do it in global config, I can't override it locally, right, on an interface. And you can, and we saw that, and we're going to see the same thing here. And so let's dive in here, and let's take a look. And what do we have here? Let's drop this back down for a little more, a little more control. So here is the LLDP packet. You can see right here, Again, it's on top of Ethernet, and there is the LLDP multicast address, 0180 Charlie 2 00000 Echo. And so that is how devices that are running LLDP know how to listen for that multicast address. Now, here it is right here, the link layer discovery protocol. Let's give ourselves a little more room with which to work, because this is going to be pretty busy here, as you might have seen just a second ago. There we go. And let's drop it down. Take a look at all of the different information you're going to see. We've got a chassis subtype, right? We get the MAC address, and it's going to give us some information here, the chassis ID, and we can see, and it lets us know we've got a Cisco device here. Port subtype, the interface name, right? So there's the interface ID that we're using on this router. There's our time to live value. We know the hello is 30 seconds. The time to live is 120. We get the system name, right? And I'll drop these out here for you. You can see I'm not going to dive into all of these. And for those of you not familiar with TLV, right? If you're familiar with EIGRP, right? The Enhanced Interior Gateway Routing Protocol, the TLV is a convention that's used to communicate specific information. In other words, bits will be set in these TLVs that will indicate certain things. Like here, it indicates port ID 2, right? And these, again, this is, binary representation where that would be 1, there's your 2, that would be a value 4, so forth and so on. And again, you can see here 2 and 8 and 1 is 11, right? So the length is 11. So TLVs are just, think of them as little packets of information with bits that are set in order to communicate specific pieces of information that are of value, right? And you can see here the TLV length is 2, and there's the time to live indicator, right? So we've got our system name, port description. So we've got information about the port description. And again, this is router 14. This is the transmission of that. Now, capabilities. And we're going to stop here for a second on capabilities, because there's a difference between enabled capabilities and capabilities in general. This is a significant difference between CDP, which shows me every possible capability that can be enabled, and LLDP, which shows me both all the capabilities that are supported, right, that this device can support. It could support bridging, and it can support routing, right? See, it's bridge capable, router capable. So capabilities shows me all the capabilities that the device supports, that it could be enabled for. Enabled capabilities shows me what the device is actually doing, which capabilities are actually enabled. And this is kind of nice, right? Because CDP gives you like this whole smorgasbord, right? This huge buffet of all these capabilities and says, here's all the capabilities that this device can do. Well, what if you just want to know what capabilities are actually enabled and being used? Well, LLDP breaks that down for us. We get the management address here, right? You can see it's going to give us some IP information on the management address. And then we get some additional information on the MAC physical configuration status here. And then let's dive into, where was one I wanted to take a look at specifically. Where is it at here? Whoops, slide over a little bit. Yes, our system name, right? So we get the system name, and you can see we get some truncated system information along with that. And it's going to give us the version number of software. Now, you might be thinking that 15 code, it's going to be supporting LLDP, because LLDP has been around considerably for a while. Not as long as CDP, obviously, because CDP was the predecessor, but it's been around for a while. But let's come over here to some 2811s, right? We'll come on to router 8 here, and this is running 15.1.4M12. And you would think 15.1 code, this is a given that we're going to be able to say LLDP run, and it's going to work. It is not here. It's not supported. And so you're obviously 15.1 code is a little bit older, but just know that this is not something that was around in early 15 code, at least not on all devices that were out there. But you're safe if you're running any recent version of code. And if I was to pull up this screen here, you can see that if you're looking at 3945, some of the ISR G2 models, or 2900 ISR G2, 15.7.3 M6 is the latest release that you should be running, and it is definitely in this release. And you can see I was here doing some downloading earlier. All right, so let's go ahead and come back over to the packet tracer activity. We're back over here on the edge router, and let's continue to scroll up. So on the edge router, I could say show IP interface brief, and there's information I can use to fill that table out. I can say show interfaces, and again, this is going to show me a lot of information about the interfaces, the MAC address, the MTU setting on those interfaces. And so now from the edge router, we're going to use SSH. We're going to connect over to the remote branch office, or the RBO. So SSH -L RBO admin. And that is at 209.165.200.10. We're going to log in with that same very hard to remember password, PASS. All right, now we're on the RBO edge router. It says, what piece of previously missing information can now be added to the addressing table above? We could actually drop in the RBO router in here. We could, the serial interface, we can grab the IP address and subnet mask, which we got on the edge router. That could be filled in, but we could add in that information, for the RBO router. And let's come back right here. All right, so now we're going to use LLDP to discover neighboring devices over in the branch, right? So show IP interface brief here. You can see again, we've got an inside interface. That's going to be gig 01. And then we've got gig 00, which is that 209.165 that's facing this direction here, right? And then let's go ahead here and make sure we capture all this. So let's say show LLDP. You can see LLDP is not enabled. We have to turn it on globally. So we'll get into global config. We'll say LLDP run. And then we're going to go into int gig 00, where we're going to say no LLDP transmit, because again, that's sort of facing outbound. And so we don't want it running transmitting devices. And we'll say no LLDP receive, right? Now, we're going to issue that show LLDP neighbor, do show LLDP neighbors command. And so it's interesting. We said no LLDP transmit, no LLDP receive, and it's asking us to run that command. So we're saying we're not transmitting and we're not receiving. So then how is it that we're getting this information here on this gig 01 interface? Right, remember, what we did was we went into gig 00. So let's take a step back here. I said LLDP run. At that moment, every interface that's up on this router is now transmitting and receiving LLDP frames. Then we go into int gig 00, and I say no LLDP transmit and receive. So when we come down here and we see the RBO firewall, what interface on the RBO edge router is actually receiving those LLDP frames, right? It's gig 01, because we didn't do anything to gig 01. Therefore, gig 01 is impacted by the global configuration command that we set, which is LLDP run, which means gig 01 is actively transmitting and actively receiving LLDP information with whomever is out on that gig 01 interface. And it happens to be the RBO firewall. All right, and so it asked about the neighboring device. What type of device is it? A firewall. We've got the name. On what interface is it connected? It's connected on its gig 00 command. So now we need a little bit more information, because we get all the capability codes here. We get the device ID, capabilities, things like that. What we don't get is the IP address of the device, right? So we'll go ahead and say in SSH. I'm sorry, not SSH. We're going to say show LLDP. Come back here. Show LLDP neighbors detail. where we're going to get a little bit more information about that device, right? We get the chassis ID, which is the MAC address, the port ID, port description. We see it's the RBO firewall, but what we are looking for here, we get the capabilities code. We can see how much time is remaining. We get the system capabilities and the end capabilities. But let me ask you this. Do we see the IP address in here? What other piece of potentially sensitive information is listed? And so that sensitive piece of information with the detail command here on RBO edge does not provide the management address. So the current does not provide the management address of the neighbor device. So let's see if we're going to see that, because that's what I was looking for. I was looking for that neighbor information. So there's router 14. I believe it's router 12 here that we've got. Sure. Let's pull router 12 up. Let's go into LLDP run. And on router 12, we're going to kick off the LLDP process. And let's say show LLDP neighbors detail. We haven't seen anything yet because we've got 30 seconds. We might be waiting to receive something from router 14. Let's give it a second here. And actually, let's go ahead and kick off our packet tracer packet capture. We should be seeing some LLDP information here briefly, and it should be going out that interface. And let's make sure this guy's connected up here. 10.0.0.14. All right, so I can ping it. And I'm not seeing any LLDP information, which makes me wonder. Show LLDP. Let's see what we've got going on here. Yeah, so it's there. Maybe I'm just not being patient enough, but there has been 30 seconds, no doubt. So R14 is sending and receiving, and there's router 12. Okay, boy, that took router 12 some time there, but we're still not seeing it. So let's come over here to router 14. Let's see if we're getting it here on router 14. So show LLDP, LLDP neighbor detail, and we're not actually seeing it. So it might be something to do with how I've got these guys connected up, because they are definitely not back to back. And I think that's what it might be. I think I've got these, and again, I've got a ton of equipment here. I think these are running into a switch is going to be the problem. So I thought I had them back to back, but they're not, meaning I directly connected to each other. They're not. And so we're not going to see that. And actually, again, another fortuitous failure, right? Because we look at this and we can see that the LLDP packets are not forwarded along. So each of these routers is sending an LLDP frame to the switch to which they're connected, but they're not forwarding that information. Now, I've got serial interfaces on router 8 and 9, but that's not going to work either, because this version of iOS does not support LLDP. All right, so we're going to have to carry on here without that. We don't see the connected the neighbor device with SSH to discover the other devices. Does not provide the management address of the neighbor device. In this activity, several neighbor device addresses have been provided in the addressing table. So we should have to come back, or we would have to come back up here and get the neighboring address of the device, which in this case is going to be connect to the neighbor device with SSH to discover other devices that may be its neighbors. To connect with SSH, we're going to use the same username and password. And let's go ahead and say show IP interface brief, and it's out that gig01 interface. So it's going to be a 192.168.3 address. We look up here, and again, I don't see a 192.168.3 address because it wants us to get onto the firewall. So let's go ahead and say SSH -L RBO admin, and we're going to go to 192.168. We'll try 3.1. And then we're going to try 3.250, and it doesn't like that. So let's drop this back, 3.250. There we go. So it's going to be 3.250. Again, that was just me kind of guessing, and I don't recall seeing that up here in the addressing table. Maybe it is. Maybe I went right by it. Yeah, I don't see 192.168.3 S3, I mean, again, we kind of guessed it, and so that's going to be the IP that we're going to use. You can see that we're here. Let's get logged in. S3 CRE7 PA55. All right, now we're on the RBO firewall. So remotely connected to the next neighbor. So let's say show LLDP neighbors. And there's some more information. So we see the RBO edge. We've already gotten onto the RBO edge. And we're looking here at a switch, right? The RBO1 switch, which we can also, it looks like they provide us information to the SVI for the switch so that we could get onto the switch and see what other information is there. So again, we can add this information to our addressing table for the RBO firewall. We have all this information here. If I was to say SSH -L, and we're going to say RBO admin, and we're going to go to 192.168, and I'm looking over here, .4.131, and S3 CRE7P @55. All right, so now we're on the switch. And let's see if that gets us into privilege exec. Or actually, we don't need to get into privilege exec, so they're probably not going to allow us to do that because I don't see a password for that. So we'll say show LLDP neighbors. And you can see that there's another switch, switch RBO2. And again, it gives us the information to get onto RBO2, so SSH -L RBO admin. And you can see how you can map the device out here, 192.168.4.133. And hold on one second. Does it want us to go back to... I may have skipped one here, 131. If I'm just reading the instructions here, place the newly information. Next time, connect to the SVI address 192.168. Okay, so it's not going to let us do that. Let's go ahead and go. Let's rerun this command and see. Whoops, pull this back here. It doesn't like the SSH command. Yeah, okay, so we've got to be in privilege exec to do this. Let me see if it's going to take this CRE7PA55. Yeah, there we go. So we can transition into privilege exec using that same secret password -L RBO admin to 192.168.4.133. And this is going to kind of wrap up everything we're doing here. SCRC7PA55. All right, so here we are, show LLDP neighbors. LLDP is not enabled, so let's get into privilege exec. S3 CRE7P @55. Get into global config, LLDP run. So we've now enabled it, and it says there's no need to configure transmit or receive options because they are on by default. Correct. All right, so let's go ahead now and say show LLDP neighbors. So there's our neighbors. What about a show LLDP neighbors detail? And there's the detailed information. Again, we don't see the IP address, and that's going to be a packet tracer limitation that we would run into. And so I believe that that is going to do it for this activity. Recording new discovered devices. All right, well, it is. So that is going to wrap up packet tracer activity 10. And actually, let me stop that packet capture. That's going to wrap up packet tracer activity 10.2.6, where we used LLDP to map a network out. And as you can see, there is a ton of valuable information there to be gathered up using LLDP. Remember, when you say LLDP run in global config, and remember that LLDP is off by default, we've got to turn that on, that you are turning it on every single interface. So be aware of that. And know that if there are interfaces, which might be externally facing interfaces, we want to get into those interfaces and say, no LLDP transmit. And if you wanted to receive the information, you could just stop right there. But if you didn't want to receive any information on that externally facing interface, you could say no LLDP receive as well. All right, thank you so much for watching. I hope this is helping you out in your studies. Best of luck to you out there, and I hope to see you in the next video.